Good morning, everybody. My name is Sherry Seligson. It is Monday morning, and we are going to continue doing some really fun activities. This is stuff that hopefully just keeps you guys occupied, something for your children to do that's educational but also fun. I really want it to be really fun, things that you can do at home with stuff that you have around the house. I'm going to try to simultaneously, while we're waiting for everybody to jump on, I don't think I can put it on my personal page, but we'll try to figure that out later. Anyway, I've been doing this over on my page, Sherry Seligson Author, but I wanted to come and do this at the Hip Homeschool Moms page as well because it's such a great group of moms, and some of you may be homeschooling, some of you may not be homeschooling. Either way, this is something that we just want to enjoy the time together, that we're put together in this place, and we want to make it productive. And so I first want to do, and I try to do this whenever we make something, I want to come back and show you how it worked out. And so on Saturday, we took a nature walk and recapped some things we did last week, which was about botany. If you didn't see those, you can see those over on my page. We went over every single day, Monday through Friday we did some, and then Saturday we did an outdoor scavenger hunt, looking for the things we talked about. But we also made some fun little dinosaur eggs. These are things you can also do with stuff you have around the house. It's basically a salt dough. If you just take, I think it's a cup of flour, half a cup of salt, and a half a cup of used coffee grounds, and mix those together, and then add just a little bit of water until it comes together when you touch it. And then you can take that dough and you can put it around little toys and let it harden, and it makes these really great rocks that look like dinosaur eggs. You see that? And so then once they allow it to dry, just air dry, or you can put it in an oven just at really low temperatures for a couple of hours, maybe overnight, and then you get these rock hard eggs that you can hide around the house or hide outside, have your kids hide them, put them in a sandbox, let your kids excavate, and then they can open these up. And this one didn't fully dry, so I'm going to just break it open and show you. I put a Lego man in there. We sacrificed one of our Lego men for this. He's going to take some major cleaning to get out of there. But there you go. There's my broken dinosaur egg and my Lego guy. And so it's something fun you can do, hopefully with stuff you have around the house. I think this is a great one because it's an excuse to make coffee, right? We've got to make our coffee. So that's what we did on Saturday. And so today we're going to actually change gears. I want to talk a little bit about, I want to go more in the chemistry, physics side of things this week. And I want to start today talking a little bit about the coronavirus, the thing that's really got us in this situation. But I want to do it in a way that's not scary, but I want to educate as much as we can, giving you some things to talk about with your kids and maybe some activities you can do to help illustrate some of the things. And we're going to end with a craft because we always have to do something fun too. So the first thing I want to do is talk about different criteria for life. Interestingly, viruses are not living things. They are basically a protein shell with some instructional information on the inside. And that instruction information is DNA or RNA. You may be familiar with the term DNA. We're going to actually isolate DNA tomorrow. We're going to do an experiment. We're going to isolate DNA. You can actually see DNA out of materials you have around the house. And so we're going to do that tomorrow. But they basically are just a shell that contain that. And so this is one kind of virus, and we know what they look like. Scientists have done major studies on them and broken down their chemical compounds. But they've also used really superpowered microscopes to see. Look at the crazy thing look at that guy. He's got legs. The top part of it right here is where the DNA or RNA instructions are, but these guys are not living things. There's actually 6 different criteria for life, and one of the criteria for life is that an organism is able to reproduce itself. Okay, and we talk about life, things that are alive and not alive. It's kind of good to quantify that because when you talk to your kids what's living and what's not, they'll say, well, a rock is not alive. Why? Well, because it sits there, doesn't move. Well, plants don't move either very much, do they? If at all, right? So are plants alive? Well, yes, they are. Why? Well, because they grow. Well, rocks don't grow. I mean, there's all kinds of things that we can talk about, but one of the 6 criteria is an organism can reproduce itself. These guys can't reproduce themselves. This is actually the bug that we're dealing with right now. The word has to do with crown, and that is because it looks like it's got a crown. Those little extensions, those are protein extensions. And so these guys, they're pretty mean. What they do is they get into a living organism and they take over that organism's cell. They inject their instructions and say, make more of me. And so they make the cell do that job. They use the cell's materials and the cell's mechanisms to make more, and then that's how they reproduce. So they have to take over a cell. And so that's very hard to fight. You might think of antibiotics. Well, antibiotics, in the word, think about it, anti is against, bio means life. Antibiotics work on living things, like they work on bacteria. Bacteria are living things. When we get sick, sometimes it's because of a bacterial infection. Antibiotics fight against those. There are natural antibiotics out in the world. Scientists discovered them by studying how organisms live, and so they discovered penicillin, which is made from bread mold. There are natural antibiotics that exist in the world because there are bacteria out there, and organisms have been designed with a way to fight those bacteria. The white of an egg is called albumin. It has a natural antibiotic consistency that fights off bacteria that might get into the eggshell and harm the developing embryo. And so natural antibiotics exist, and scientists learned how to collect those antibiotics to help us to fight off the bad guys when they infect us, but they don't work for these guys. And so we do have a beautiful immune system, though. Our immune system helps us to fight those guys off. They don't do really well. This particular one does not do well in warm temperatures, so we get a fever. It's because our body's saying, get hot, so we can fight off these guys so they can't work really well. We also have to build and strengthen our immune system. And so one of the ways of fighting that off is to eat well, to get plenty of sleep, to give our body the ammunition it needs to fight these guys, because our body has amazing cells that travel around our bloodstream, and they're kind of like little, I like to think of them as little tanks that go around and they just fight off the bad guys. And so we want those tanks to have all the ammunition they need. And good ammunition involves vitamins and minerals and good sleep and plenty of water, but also it involves washing our hands really, really well. And I love to do this. This is something to illustrate. I used to do this with my students. I'm a homeschool mom, and I taught co-ops and science classes. I write for Apologia science courses. This is glitter, okay? I don't like glitter. I don't know about you guys. It's one of, as a mom, it gets everywhere and it never, ever goes away, right? You just can't get rid of it. But you can do an experiment with your kids like this to illustrate to them how quickly it is, it's easy to spread a virus. If you just maybe got a little bit of glitter, or maybe gave them a glitter card, okay, you know those greeting cards that have glitter on them. Just let them hold it for a while and look at it. I know, it's hilarious. People are giving me laughs. But you just touch the glitter, and they hold the card for a little bit, and then you have them look at their hands, and they'll say, oh, you can't see it, but I've got glitter on my hands right now, okay? And so then just let them go about their day. Say, okay, just don't touch anything. Don't go wash your hands right this minute, but go do some things. Next thing you know, everybody in the house has this stuff. You're gonna find it on their face. You're gonna find it at the table. It goes everywhere, and it doesn't get off of their hands unless they really, really scrub their hands with soap and water. Perfect example, right? Okay, I'm gonna try to get as much of that glitter off because I just don't like glitter. It is like a virus. Okay, it's the crafting virus, if you will. Okay, so we want to wash our hands, and so I want to talk about the properties of water and how and the importance of using soap. What soap does. We talked a little bit last week, if you were with me, about how water has an amazing ability called hydrogen bonding, and that helps it hold together and actually forms a skin on its surface. I did this last week, but I'm going to do it again because when I did it last week, it didn't work really well. I think I had some soap residue in my water. But you can do this as well too. And just a quick illustration of how soap will cause the things in water to move away. We need to use soap and water to wash our hands well. And so I've just got some pepper, and I'm going to sprinkle it on water. It's just a bowl of water, nothing else in it, just from the tap. And so I'm going to see if I can hold it up close so you can see it better. I just have some dish soap, and I want to put a little bit on my finger. Okay, dish soap. Let me stand up so you can see better. Okay, let's see if we can watch. Now watch when I touch what happens to the pepper. Do you see how it separates like that? It actually moves far away, and that's because of the nature of water. One of the things is it does something called hydrogen bonding, and so it's basically like the little water molecules are holding hands. It's a very minor type of bonding, and so they hang together, but soap breaks it up. And the reason why soap does that is soap is made up of a very gigantic molecule. Molecules tend to have either a neutral charge or no charge, or neutral charge at all, or they're positive or they're negative. Well, Water has it's called a polar molecule. It actually has slight charges on it. I like to use my fingers like this as my water molecule. Most people know water's H2O, right? Okay, so it's two atoms of hydrogen and one atom of oxygen. So this is my hydrogen, and this is my oxygen. And they're actually oriented in a 105-degree angle, but that's not 105 degrees. But something like this. So this is my water molecule, my fist and my two hands. And so this is another water molecule. Well, oxygen is a huge atom compared to the tiny little hydrogens, and so it pulls stronger on the electrons, which are the tiny little negatively charged parts of atoms that whirl around the center of around the outside of the atom. And so it pulls on those negative electrons greater than these little hydrogens. So most of the time, the electrons are over on this side of the molecule, which makes this side a little more negative and this side a little more positive. And so when other molecules get together, just take a screenshot of me doing this. Okay, you've got your positives being attracted to the negatives like that. And so when they're attracted like that, they stick better. And that makes this, this beautiful skin. Hydrogen bonding does that. But soap is a really, really long molecule. And one end of it is polar, meaning it has slight charges on it. Polar things like to stick to other polar things. Non-polar things that don't have any charge like to stick to non-polar things. And one example of polar material is water. So I'm going to show you this. It's just a vase. I've got some plain water. Okay. And then I have oil. Oil is a non-polar molecule. So it doesn't have any charge. And so it doesn't like to get next to water. And so we have two terms, and I like to use a lot of vocabulary terms. If you want to take this and make a little vocabulary list and add that to your day, you can. Hydrophobic and hydrophilic. Hydro means water, and phobic means fear, like a phobia of some sort, and philic means love, like Philadelphia is the city of brotherly love, right? So hydrophilic means water loving. So water loving means it's polar. Hydrophobic means it doesn't like water. So this is what oil is. And so when I pour the oil in, you may have seen this done before, but I think it's just kind of fun to do in light of what we've been discussing and to help understand what's going on, both chemically, because I love the education part, but also to talk a little bit about the what's going on with washing our hands. Now I'm going to see if I can do this. I wanted you to see, maybe I'll use red. I wanted you to see the water better. And so I've got food coloring. Now food coloring is actually hydrophilic. It loves water. So you can see it's sinking down below the oil right now. And actually it's going to start raining down in the water once it gets mixed a little bit. Let me do that a little bit so if I can get my pen down there and just stir it around a bit. Oh, I probably should have mixed it ahead of time before I put the oil in. Not a big deal. Okay, you can do this though if you want. You can see it's starting to blend in with the water a little bit. So that's kind of a fun thing to do as well. But what I really want to show you is what happens when we add soap. I didn't bring a spoon, but that's okay. So we've got this together. I'm going to add some soap. Now the soap, remember I said it's a long molecule and it has a hydrophobic end that mixes with oil, a hydrophilic end that mixes with water. And so soap kind of connects the two. And so when you stir it together, let me use one of my, I've got a skewer right here. That will probably work. When I stir it up, look at that. We got this pink mess, right? You can see that pink mess? Okay, that's because the soap is connecting the two. So when you're washing your hands, there's oils on your skin. Your body produces natural oils, and that's what the like bacteria and viruses and other things can stick to. And when you use just plain water, it just kind of flows off. It doesn't get it clean. When you use soap and water, you're mixing them together. You're creating this. And so the soap will pull the water plus any other critters that are on your skin as well away. And so that's why we need to use soap. It has a property that's both hydrophobic and hydrophilic, and it connects hydrophobic material to hydrophilic material and helps us to clean our skin so that these bad guys don't get in. All right, that's the reason why we do this. I love using visuals, so I use lots and lots of visuals on this one, okay? All right, so that's basically the science behind what we're talking about, but I also wanted to do something that's just kind of a fun activity, and I don't know if you guys are gonna laugh or not, but I'm gonna use these. These kind of are the the darlings of the year right now, right? These are empty ones. And so it's probably sure that you're going to have these around the house. And so I was thinking, what can we do craft-wise with these things? And I thought it might be fun to make some pom-poms. And the kids can make these. They can make little animal shapes with them, and then they can play with them. Again, I want play value. I want educational value as well, but I want play value. So we're going to actually make a little bunny rabbit with these with the toilet paper rolls and some yarn. And so if you've got some yarn hanging around the house, I'm going to show you how to use toilet paper rolls for this. You don't need to have very fancy things to do it. So I'm just going to take my my string, put the toilet paper rolls together, and then I'm going to start wrapping. I already made one, and I want to make two because I want to make a bunny. You can make whatever you want. You can keep them just as a pom-pom. Actually, it kind of looks like that coronavirus, doesn't it? You could play snowball, indoor snowball fights. However you want to do with these. Have the kids hide them, play hide and seek. Things that they can get moving around with, and that's really, really important, isn't it? And so I'm just going to wrap this around these two rolls till I get a nice big poof at the top. Let's see. I want it to be nice and rounded at the top so that we get a nice big poof. So here we go. We're going to keep going. Almost there. It goes pretty quickly. All right. That looks pretty good. Okay, so now I'm going to cut a tail. I'm going to cut another sheet piece like that. I have my paper towel rolls, and I have a string. And so I'm going to take this string and put it between the two paper towel rolls, run it around the underside and back between so that it comes around. Let me just show you real quickly here what I did. This isn't long enough. I need a longer string. Right there. Let me do it again. So I'm going to bring the string up between these two paper towel rolls and up between these two paper towel rolls, just going in between and around. Then I'm going to tie it into just a simple knot, just one time, like that, to hold it together. And then we're going to pull the paper towel rolls away, and you can tie the knot tighter. So let me just slide them out. I'm calling them paper towel rolls. You could use paper towel rolls or toilet paper rolls. And then just pull this really, really tight. You get it nice and tight in the middle. So you don't need any kind of fancy pom-pom maker or anything. You can just use your used toilet paper rolls. So there we go. Now, hopefully the kids don't see that and want to just take all the toilet paper off of the toilet paper roll before it's used. That's not the purpose of this, okay? This is just something fun for you guys to do. And then be creative. Think about some things you can do with this. So then you just cut the loops like that. And then you've got this really, really floofy thing. You need to trim it to make it more pom-pom-like. And so it's actually going to get a little bit smaller, actually much smaller, to make it tighter. So I'm going to cut it like this. And you're just going to have to kind of fluff it and cut it, give it a nice little haircut. This is a great opportunity to build scissor skills with your kids, your littles. Your older ones can make stuff out of this, like they can use the pom-poms to make various animals, which is kind of fun. Once they make an animal, have them make an illustration of their animal, and then tell a story about the animal. Write a book, make a little booklet. I mean, this is the time to be reading and writing and having fun, but in a fun way. This is our assignment for the day. This is hey, what else can we do? Tell me the name of your guy you're just gonna make. So I'm gonna make a bunny today. And so we'll give him a name, and you can tell a story about the bunny. Where did he go? What kind of problem came up that he had to solve? And so that helps them think about some things, and they can write it. They can draw a picture. How easy is it to draw a picture of a pom-pom bunny, right? It's just a couple of circles. And then I'm going to give him some eyes and some ears and a tail just with paper or cardboard that I colored and got ready. If you have googly eyes, oh, wow, yeah, googly eyes. I think googly eyes are just so fun to have. You can put googly eyes on anything, and it instantly becomes fun, doesn't it? I mean, come on, put a pair of googly eyes on your stapler, and it's just so cute at that point. Okay, so here we go. Here's our really quick pom-pom. If I had more time, I would probably make him a little rounder. And then I just got, you can use regular glue. You can use, I'm going to use hot glue because it works a little faster. Just to kind of show you, I'm just going to stick a whole bunch of hot glue on this side, stick them together, and then Got my little rounded bunny right here. I have some ears. I'm just cutting out a cardstock, colored with crayons. Nothing fancy, just something fun. Got a little bunny ear right here. I'm gonna stick it in. Another bunny ear. Again, if you don't have hot glue, you can use regular glue. And of course, you gotta make it alive by giving him some eyes. Talk about what things are living and what things are not. Our bunny's alive. Why are they alive? What are the criteria? I'll make a list of those and I'll put them in the comments on this video so you can go over those with your kids. What are the criteria for life? What makes something alive? Gotta give him a bunny tail. This is just a cotton ball. All right. And there we go. Okay, really fast, cute little bunny. There he is, cottontail on top. Something your kids can play with, something to keep you going. I hope you guys have a great Monday. We're gonna come back tomorrow. We're gonna talk about DNA and what's going on inside DNA and how that works, instructions. I'm gonna involve some Legos with that. And then we're gonna go into some chemistry and some physics the rest of the week. Please join me. We're gonna try to continue to do this at 11 o'clock in the morning Eastern time every day, and have fun with this. All right, again, I'm gonna put in the comments a list of the criteria of life. Thanks again for joining me.